Good morning, everyone, and welcome to the continuing Solid Edge webinar series. My name is John Pearson, and I'm the Senior Application Expert at Designfusion, and I'll be teaching you the basics of assembly creation in this session number 7. Just a reminder to those of you who haven't joined us before, if you're new today, this is a very rudimentary training designed for anyone who does not know Solid Edge, focusing on mainly managers and supervisors who want to understand what their staff is doing, new employees who want to get a leg up before attending a full fundamentals course, or prospects who just want to see some of the capabilities, or any other interested individuals. This in no way replaces the fundamental course, which is a full week course to begin with. It's primarily designed to introduce you to some of the capabilities in Solid Edge. At the end of these sessions, you'll be able to have a good understanding of the basic task, as well as be able to do a few of the basic tasks, as well as be prepared for the self-training tutorials. This is session number 7 of this series. All the other sessions, if you missed any of the previous ones, you can go onto our website at designfusion.com, click on the COVID-19 response icon, and click down here where it says check out this link. And this is where the previous sessions are recorded and broadcast. So you can catch up, or if you missed any, you can join them. Notice under each session, we also have the links that are shown on the second last slide to do further activities, tutorials, and so forth. Just a reminder, it's PowerPoint presentations with embedded demonstrations and/or videos. At the end of each session, you'll be shown a page of downloadable activities or tutorials, as well as alternate sources for more information. There will be a Q&A at the end, and that Q&A you can either ask your question or email us your question. And as I've mentioned, these presentations are being recorded for rebroadcast later on. So let's have a look at basic assembly creation. If you've been with us through this series, we've learned how to make parts both in ordered and synchronous. We've learned how to make sheet metal parts in ordered and synchronous. Now we're going to learn how to assemble them. In the assembly environment, first and foremost, it doesn't matter. There's no such thing as an ordered assembly or a synchronous assembly. There's assemblies of synchronous parts, assemblies of ordered parts, or assemblies of mixed parts. We don't care how the part was made. We just want to know there's an existing part that we can put together in the assembly. We start creating from the bottom up. We start by launching our assembly template. Whatever standard you're using, choose to use the isometric template here. We drag the parts into the workspace from our parts library, and then we apply assembly relationships to connect these parts. Unlike the sheet metal or part environment, as soon as two solids touch, they do not automatically unite. We want to keep the parts separate inside of the assembly, so we have to put them together with assembly relationships. We save the file in Solid Edge, and we end up with something similar to what you see here. Again, notice I've set this up for training mode here. If you want to set yours up the same way, you can download the first activity from session 1. Other than that, it's very similar interface. Some of the things are slightly different. Obviously, we have assembly commands in the ribbon bar. And instead of seeing a history or sequence of parts or features, we actually see a history and sequence of parts and sub-assemblies being put together in our Pathfinder. All the rest of the interface is virtually identical. You got your quick access toolbar, your prompt bar, your command finder, and so forth. So to start, we start by placing a part, and you can do this one of two ways. You can actually click on Insert Component, which will open up the parts library, or you can go just to your edge bar, locate your parts library tab, and to open it from here. Parts library is a window into your database. So you search for the folder that contains your part, and then you click on the part, and a highlight will show up in the bottom pane here. The first part you place is grounded in space. In other words, what happens is it takes the coordinate system of the part and aligns it with the base coordinate system of the assembly. Any other part you bring in, you must apply relationships. We're going to show you a few of the more common relationships. Some of the other relationships is advanced stuff, and they would probably confuse you more than answer any questions. So to start, we bring in our grounded part. In this case, this assembly here is our grounded part. And then we bring in an additional part, and we apply, in this case, we're applying a mate relationship. So the planar face of here has to align facing the planar face of the underside of this section here. And what happens is that'll move over and create that relationship. You then would assign a second relationship. For example, I want the axis of this to align with the axis of the hole. It moves over. And then we could assign a third relationship if necessary to control the angle that this is sitting in. Usually it requires three relationships to fully position a part, one in each plane, but you do not have to fully position parts. For example, you may be putting on a wheel and you want to keep it so that it can spin. You wouldn't have to lock down that rotation. So let's have a look at how this works. And we'll start in a new assembly here. Now I'm going to show you three ways of placing this. There's actually at least five ways of doing the alignment of parts and positioning parts. I'll show you probably the three most common ways, and you'll see that how easy it is to put this together. If you have ever played with building blocks as a kid or put together models of cars or airplanes, that's all we're doing here. We're building a model. So I can start by clicking on Insert Component, which opens up my Parts Library tab, or I could go in there and look for it myself and open it. I'm going to bring in this first part here. And you'll notice when I click on it, I get a preview of it down here. And then I actually grab the part up here in the top pane, drag and release. I can also double click on the part in the top plane, and this positions it. Now you'll notice I'm going to go and I'm going to show the reference planes of the component, and you'll see that these reference planes line up with the base coordinate system of the assembly. And this tells me, this is just to show you actually how this is aligning when you bring in your first part. So let me just hide those because I don't want to see those again. Notice if we go back to our Pathfinder, we have this part in here. And if I click on this part, you'll notice down in the bottom pane here, it's grounded. We also have a little blue symbol on there to let me know that it's grounded. So this is fixed in space. And so as a rule, when you're building an assembly, you're going to start with a main component, and you're going to, so a frame or some base part, and that'll be your anchor point. This can always be changed later, but it's good to start with a base. So if you're building a bicycle, for example, you're not going to start with the handle grip. You're going to start with the main frame, for example. Let's go back to our parts library. The second part I'm going to bring in, I'm going to click on here. Now you'll notice down here, just even some experienced users may not be aware of this, is that if you actually hold down your middle mouse button, you can rotate this. And by doing so, I'm changing the orientation that this is going to be dragged in here. So now that I've flipped this over, as I bring this in, it's going to maintain this orientation. So if you want to sort of pre-orient how it's going to come in, you can do that in the lower pane here. So we've got the part in. You'll notice it's transparent, and what's happened is this dialog has popped up. So I'm going to show you actually probably best to go this way first. Let's do the sort of the traditional way, where I'm going to go and select one of my relationships here. I'll select mate, I'll select here, and I'll select here. Notice how they've come together now. I've mated these two faces. This is still highlighted, so now I'm going to go up and select Axial Align. I want to align the axis of this hole with the axis of this hole. And then I want to align the axis of this hole with the axis of this hole. And you can see now that we've fully positioned this part. If we go back to our edge bar here, Pathfinder, you'll notice that if I click on this part, it shows me the relationships that I've applied here in the lower pane. Let me delete this. Let's do this again. You'll notice this time I will not rotate it or pre-orient it here. So when I drag this in, it's in the same orientation down here. Now you'll notice here we have our first relationship is something called flash fit. Flash fit allows us to reduce the number of steps for placing the component. And it does this by taking its best guess at what you're going to align with. So I'm going to align this, but I'm going to align it on this side here. Now you notice that it's actually done a planar alignment instead of a mate, but I can just hit the flip button here or hit the F key and it'll flip it back and forth between mate and planar for me. I'll go and pick this circle here or hole. It looks for now it's automatically put into axial alignment, and I'll do the same over here. And let's make sure we get that. Oops. Now, I actually grabbed the edge instead of grabbing the hole. So I'm going to escape out of here. When this happens, you simply click the part, hit Edit Definition again, and it puts you back in to this mode. So now I can select that, because it's easy sometimes when you're picking quickly to make a mistake. And if that happens, it's easy, just hit the select tool, pick on the part again, and pick Edit Definition. So now that we've got this, I'll just save this part here. Now, a third and probably the quickest way to place things is to use what we call capture fit. Now, capture fit only works if you've already predefined some parts and the relationships of some parts, and if you're going to be using parts over and over again. So what you do is you select the part and you go up and pick on capture fit. Capture fit remembers the relationship that you've placed in here. And you can actually remove ones that you've put in there perhaps, and just remember these main ones, or you can add, you can remember 1, 2, 3, how many you want. We'll say okay. And now when I drag this part in again, I can go in and select. Notice it's already saying what face do you want, and it's already put the mate relationship up here. And now it's going to axial and axial again. So 3 clicks and it's fully positioned. Now, when you use Capture Fit, if you have this turned on, it's going to remember this part, these relationships on this part, even in different assemblies. So you're actually assigning these relationships to the part in the external database. So if I open another assembly a week from now and drag this part in, it's going to remember these relationships. If you uncheck this here, it only remembers it for this assembly. Now, in the event that you check it and it puts it in the parts library, and you happen to bring this part in and you don't want to use this relationship, all you do is go up here, pick your select tool, pick the part again, and hit edit definition. And now it's like it's a brand new part without any relationships on it. So if you're going to use these relationships 80% of the time, it makes sense to put a capture fit onto it. So those are 3 of the most common ways to utilize the placement of parts here. As I said, there's a couple of other ways that we can do it, but those are the 3 most common. Let's go back to our PowerPoint now. So let's review some of the common relationships, or at least the most common relationships. We have mate relationship, so face to face. Now, keep in mind that they don't have to be touching to have a mate relationship because it's looking at the plane of the face, not the face itself. Same with planar alignment. They're side by side, so both faces facing the same plane. And here you see they're not touching, but they maintain a planar relationship. Axial align. The axis of this cylinder aligns with the axis of this cylinder. And the size of the cylinder or holes that you're aligning do not matter. You can actually put a large cylinder into a small hole and create an interference situation. We allow you to do that. We have interference checking tools for later. But for example, if you want to put in a wood screw or sheet metal screw, you would anticipate interference. So we allow that. Flash fit. Flash fit does rapid positioning based on your selection of planes. So for example, if you select 2 planes like this, if the planes are closer together, less than 90 degrees apart, they will create a mate relationship. Greater than 90, they will create a planar relationship. Simply click on the flip command or the F key on your keyboard to toggle between the 2 selections. If you happen to pick 2 holes, they will automatically align them based on the axis. So it's a great way for doing some quick standard placements. Another command we have is the insert relationship. The insert relationship is actually a combination of 2. You're first prompted to pick 2 faces and then 2 axial alignment elements, so like a cylinder and a hole. This was really designed for placing, you know, screws, bolts, and so forth. So at the end of this placement, you will not see an axial relationship in the toolbar. At the lower pane, you'll actually see a mate and an axial reline instead of an insert relationship. Unfortunately, everything in this world is not planar or cylindrical, so we have to have other relationships. Connect is one of those relationships. We can connect key points, for example. So here's a image of a barbecue cover, and we're connecting the corner points to apply relationships to it. Parallel relationship. This edge is parallel to this edge. Tangent relationship. This face is tangent to this face. Angle relationship. you can create an angle relationship between two parts. Now, for some reason, people have trouble with the angle relationship. So let me demonstrate it for you. It's actually quite easy once you understand, and it's usually the fourth prompt that they get stuck on. So let's bring back our solid edge here, and just bear with me while I grab this window. And let's open assembly that I have set up here already, and this one here. Now, just while I've got your attention here, notice there's this option here. If you go down here and you can pick assembly document, or you can pick top level assembly. If you pick top level assembly, only the top level assembly parts will show up. So if you have sub-assemblies in there, sometimes it's difficult to know which is the top level. By selecting here, you can go in and pick top level assembly. So here we have our part. Let's have a look at this. And I'm just going to hide the reference planes for clarity. So notice that this part actually has two relationships with it. It has a relationship here and a relationship here. I'm actually going to delete this relationship. So if you notice, I'm highlighting, I'm clicking on the lower tab, the relationship there. If I right click, I'm given options to do here, as well as a edit toolbar across the bottom. I'm actually going to go and delete this relationship, and that allows me to go in and apply others. So I have this planar align relationship between the two front faces. I'm going to select on this and hit the edit definition. And I'm going to go in and create a connect relationship. So I want to connect the midpoint of there to the midpoint of there. Now, so these are connected at the midpoint. What prevents it from turning around the midpoint here is these two faces are aligned planar. Now I'm going to go and put in an angular relationship. And so when you do an angle relationship, it first tells you to click on a plane or linear element to measure to. So I want to measure to here and to here. And then it's this prompt here that people get confused with. It says click on the plane on which the measurement will lie. So by clicking here, if we go back and edit this now, let's use our select tool. By clicking here, I'm telling it that I want to look at the angle from this face that I picked. Okay, now, right now we have a 0 angle in here, so I'm going to change that to a 45. And you can see by picking on this plane, I'm looking at the angle. So the third prompt that you pick is sort of the orientation that the angle is going to be measured as if you're looking down on it. Okay, it's like the front view, if you will. The other thing that confuses people is you'll notice down here we have this little number 1 and it's angle format. If I click on this, it has up to 8 different relationships or positions to measure from. So right now I'm measuring this angle from, let me just bring that back. Sorry about that. I'm measuring this angle. It's showing me 45 degrees. Perhaps I want to measure that differently. If I'm measuring off of a print, perhaps it's showing me the measurement from this side. So by clicking on that, hitting the enter key, you'll notice what happened here is I just switched where I'm measuring the angle from. So you can go in and do that and make changes to the angle just by editing it. So let's make this 75, or we can go in and go back to 45. And you can see we can have various positions just by adjusting that angle. So that's how the angular relationship works. And again, just remember that when it asks you to pick a plane to measure from, it's just asking you where the orientation of that angled measurement is all it's asking for. Some of the other commands there, center plane. With our center plane, we do it two ways. We can either measure off of a reference. You have to turn on the reference plane of the component, and you can say, I want to align, if you pick single, I want to align this between this face and this face. If you pick double, you can align these two faces between these two faces. So we have a single or a double prospect there. With some of these relationships that I've shown you, we also allow you to do offsets. So for example, you can offset between the two faces by 10 millimeters or 20 millimeters, whatever you want. That's known as a fixed offset. You can also do what we call a floating offset. Floating offset says, I don't care what the distance is as long as these two faces are still facing each other. So it's a wild card, if you will. It's ideal in situations like this. Notice here I have an axial alignment in the center, so this is aligned axial with this. If I had a fixed distance here and I modified the height of this rail, I would get one of these relationships would fail, and I would have to go back and fix it. But if I modify the height of this rail, this axial alignment will move that up with it, and because it's floating, it doesn't care what the distance is. So it's ideal for situations like this. And we also have the ability to display reference it planes, coordinate systems, sketches, this type of stuff that was used to create the component that we're placing. This helps us to align sometimes where there's a difficult alignment. So let's have a look at this. Let's bring back our solid edge. And first I'm going to go back and open, actually let's go to browse. And I'm going to open that previous assembly that we looked at. And you'll notice here, if I click on here and I go and select the mate, I can go in and change the offset here. So I can say, let's make that 10 millimeters, and it puts in a 10 millimeter offset there for me. As I'm placing this, I can also define the offset. So you'll notice if I go to edit definition here, we have the ability to predefine the offset before we pick the final face. Now let's open a new one, and we'll go into a brand new assembly. And we'll go to our Pathfinder here. And let's see what we have here. We'll drag this block in. And we'll go and drag in this sphere. Now, although they've improved solid edge now, so you can actually do a connect between the center of the sphere and this origin, this is a good example of showing you some of the options here. I can actually go in and turn on construction display icon here, and I can say, show me the coordinate system, show me the reference plane, and so forth. So I'm going to say, show me the reference planes. So these are the reference planes that were used inside of this sphere part. So what I can do now is I can actually go in and create relationships between the reference plane and the assembly coordinate system, or assembly part, or parts, I should say. So I want to align that now with that. Oops, I already did that one. Sorry. Let's do that again. And we'll select the part, say edit definition. And now what I want to do is I want to align this with this. And so now that this is done, I can hide the components. Normally it does it automatically for you, but because I did a wrong pick there and exited out, it stayed on. So there you go. It's now fully positioned using the construction geometry, such as reference planes, that I used to build that part. Now, this is quite useful when you get a complex or challenging positioning scenario. For example, I have this O-ring and I want to center it in this slot. I can actually position a plane at the center point using a global plane in the assembly. And if I've drawn this centered on, around 0, 0, I can then turn these on and align this plane with this plane, and that perfectly centers it inside of a slot. This is the type of examples that it's quite useful. If you have Solid Edge, you can go into see more examples of this into your Solid Edge help, type in reference planes in Assemblies, and it'll talk you through the process as well as give you several examples of where it could be used. So that's reference planes in Assemblies. If you take my fundamental class, I actually make you write that down. So you remember, if you get stuck, how you can use underlying geometry. Now, another way of doing assemblies is what we call a top-down process, where you can open up the assembly and build the parts inside of the assembly. Usually what we get is a combination of the bottom up and top down. So you'll have some parts predefined and you'll build some parts on the fly. So I'm going to show you a couple of examples of how you can do this. And to start with, you're in the assembly, you've got your assembly saved. You're going to start with something called Create in Place. Create in Place is found right beside Insert Component. So one of the what you can do is when you click Create in Place, you're going to define the template. You have the option to select material and how is this going to orient with relationship to the assembly. So for example, when you first click on this, the dialog will come up and prompt you for some information here. Do you want to ground the parts when you place it? Where do you want to save it when it's saved? How do you want to orient this? And do you want to create in place automatically, or do you want to create an empty virtual component just for now and edit it later? Once you've done that, you're going to go in and you can use the modeling tools to help you rapidly create, including capturing edges of the part. So let me demonstrate this. Let's bring back our Solid Edge. And we'll exit out of here. Let's go and open this one again. And you'll notice in here that I have a hole in the middle here. Let's assume that we need a tight fit plug in there. Just for argument's sake, we'll go in here and we'll see that we don't have any plugs. So we realize we have to build one. So I can go in and say create in place. Now I'm going to align. I want the center plane or the base planes or the 0, 0, 0 of my part to be indicated by a graphic input. And I want to have that, and you'll see why in a minute. I want to have this centered at the bottom of this recess here. And then I'm going to use my isometric part as my template. You can browse to the full template list if you want. Do you want to add material at this time? I'm going to say no. And do I want to have them all grounded? No. So I'm going to say accept. It's going to prompt me for a name and a location, so I'm going to say plug. And then it's going to go open up my part, my plug part that I've just created. Now, if you go to your View tab, you can say show or hide previous level. So right now, hide previous level is on, so I'm going to turn that off, which shows the underlying components in that assembly. Now I'm going to do that because when I draw my part here, and you'll notice we're in the ordered paradigm here. When I draw this part, I want to use these edges. I don't want to do any measurement or any guessing. So I'm going to go in and start by creating the extrude command, and I'm going to select for my base plane, I'm going to go in and select this plane here. Remember that plane there is at the bottom of that counter bore. Now I'm going to go up and use this command that I showed you the other day called project to sketch. And I'm going to allow, notice how it's saying allow to locate peers. If you have trouble locating your peers, go to your tools and make sure that's turned on. Because I said allow to, I don't have to worry about that. So I can go in and select, let me just put this over here for now. And I should be able to select here, and it's not letting me. That's weird. Let's turn this on. Oh, I know why. My bad. Let me get out of here for a second. And let's do this again. Let's go sketch. And let's hide the... I want to grab the base plane here. And let's go and click project to sketch. Now, if this was a loose fit, I could say project with an offset, but because it's a tight fit, and for some reason it's misbehaving today.
Your select is set on wireframe chain. That's not going to pick up that single entry.
You're right. Let's go back. And do that again. And say okay. And thank you very much. There we go. And we'll select the inside there. And now I can utilize this using a non-symmetric approach and go down to pick up right there. Okay, let's do that again now. And we'll select this plane and repeat that process, except this time we're going to grab the outer side and accept, close the sketch, and protrude that up to the top here and hit finish. Now what we've done here, I hope you've noticed this for the newer users, we've actually gone in, we didn't have to measure anything, we didn't have to guess at anything, we actually used the edges of existing parts to create this. So just for clarity, I'm going to go to my View tab and I'm going to paint this part. So we use Part Painter and we pick a color, and let's just pick, we want something bright. Let's go with steel, and we'll select the whole body. Nice bright orange color. And then we can close and return. And we now have our part positioned. Now, keep in mind, and this is important if you're new to assembly with type work here, that this is linked. Actually, this one isn't because I had the link turned off, but you can create this linked to the inside edges. So in other words, if this size adjusts, the hole adjusts, so will the plug. That may be good, but unless you're using this plug in another part. And we teach you how to deal with that situation in the fundamental course. So we now have this plug fully created and positioned there. So let's go back to the PowerPoint. So there you use the project to sketch command. Another way of doing this is using what we call an interpart copy. Now, interpart copies can only take place when you insert in, or IPA, they call it in-place activate from the assembly, okay? You can't just open a part and do an interpart copy. You need to be inside that part within an assembly to use this functionality. And what it allows you to do is select face or faces of an underlying assembly component and turn them into associative or linked, excuse me, linked construction surfaces. Once you have a linked construction surface, you can use multiple techniques, including the project to sketch to grab the edges and so forth to make your model. So I actually have this nice little demo that I've done to demonstrate how this works. And it's going to use a new command that we didn't introduce to you already inside of the part environment. So let's go and open up our valve here. And you'll notice we have a nicely assembled shutoff valve. And maybe I get an ECO or a revision change request asking for, saying that there's some leaking going on around here. Can we put in a small gasket? So I'm going to go in. First of all, I'm going to look at this part here, and I want to make some space for that gasket. So I'm going to go in and I'm going to put in a 1 millimeter offset there. You'll notice in this case, the bolts moved up with it because they were attached to the top planes. Otherwise, so I don't have to go in and adjust my bolts here. So I now have my 1 millimeter gap. And now I'm going to go and do a crate in place. And I'll just use coincident with assembly origin in this case. And I'm going to use a metric part. And we'll call this gasket. And I'm going to show, notice I've copied that up onto my quick access toolbar there so I can easily pick it. And now what I want to do is I want to go in and I'm going to do an inner part copy. And basically what we're going to do here, and why, okay, part copy. No, hang on, let's do this again. Let's save this first. And we're going to in place activate into here. And it's not activating. So we have a situation. Now, if this happens, there's a couple of places you can look. First thing you want to do is you want to make sure you go into your options tab here. Go to your assembly tab, inner part tab, and there's the culprit right there. I have that turned off. So I'm going to click on here, and I have to tell the system to allow me to do this because some companies don't want people doing that because it can create internal links. And we do have some companies that don't like that. So we do have this option here. So I'm going to apply and say okay. Now we can edit back into our part. And now we'll go up to, and you can see now this is active. So we're going to inner part copy. I want to copy off of this part, and I'm going to hover here, and I want to grab the face. Notice my selection is set to face. I'll wait for my quick pick to come up, and I want to pick that bottom face there. And I'm going to accept that. Now I'm going to go up, I'll hit finish, and then I'll hide the previous level. So I have this perfectly aligned face that it happens to match the exact size and shape of my gasket. All I have to do is I can go in and use the thicken command. Select this. I want to thicken this by 1 millimeter in the downward direction and hit finish. And like I did before, I'll go and paint this. And let's paint this black. Now, just the next slide I'm going to show you is actually going to show you the paint capability. You'll notice that we can paint just a face, feature, body, by feature type. We have a list of predefined colors in here. We always recommend you paint this inside of the part. We do have an assembly override. And if you want to create your own colors, you go to Styles, Face Styles, there's the list of colors. So you can go in and create a new one, and you can base it on an existing one, give it its own name. What kind of edge color do you want? What kind of face color do you want? What kind of textures do you want? And so forth, reflections. So you can get very creative. If you know the HSI number or the RGB number of a color, you can get exact colors. And once you've created that, that will show up in this list. Now, if you want it to show up in all your lists, so if it's a permanent color, I suggest adding it at the template level. Okay, so now what we'll do is we'll close and return back into the assembly. And there is your new gasket created without having to do any measurements or any sketching for that matter, simply by using this inner part copy. So just remember, if you're going to use inner part copy though, and it's not working, I normally keep mine turned on all the time. I turned it off last night so I could show you how to turn these on, because if I don't turn it off, I forget to tell people about this. So here is your inner part copy. Make sure they're turned on. But before doing this, always check with your company to make sure they're okay with that. I always have a saying in my fundamental class, just because you can doesn't mean you should. I show you the tools. I don't want your boss calling me up, giving me heck for teaching you something that they don't want you to do. Unfortunately, I don't know all the rules of every company, so I rely on you guys to filter out what you can and can't use. So there's the part color. So if you want to paint parts, and it's a good idea to have different colors so you can distinguish them. An entirely gray assembly is hard sometimes to distinguish the separate parts. And in case you're wondering, yes, you can use things like wood grains, rock grains, granite images, this type of stuff. That will go in your texture tab on that color, the face style dialog. So there's the links to practice what I've shown you. So we have a couple of tutorials. One's building a slider assembly. One's building a roller assembly. And Also, assembly modeling self-paced course is available. There's obviously a lot of stuff that I haven't shown you. I haven't shown you how to explode an assembly. I haven't shown you some of the advanced relationships, creating motors, using the assembly relationship manager, all this different type of stuff. We will be showing a little bit more in assemblies tomorrow, working with the advantage of having synchronous or integrated parts. But keep in mind that our assembly our assembly course is a 3-day optional 4-day. But I've shown you probably about 75% of what we show in the fundamental course here for assemblies. It should be enough to get you going and enough to make you understand how to use these tutorials and self-paced course. Also, don't forget our YouTube channel and our blog is there for you to access. And there's some nice examples on both. So just before I open it up for questioning, just remind you that you can send a question to the support at Designfusion. Again, you can make that a lowercase d if you want. Tomorrow is probably my favorite session, is the integrated modeling and the benefits of it. And if you need a link to this, you can go to this website to get the link to log into here. So we'll be back tomorrow at 10 a.m. With the integrated modeling. If you're at all interested in synchronous, you should really attend this one. So without any further ado, if you have any questions, just unmute your mic. I've given you the capability to do that and ask away. No questions? Well, good. You can email us a question if you don't want to speak out loud. That's fine too, and we'll get an answer to you. I'll leave this page up for the next couple of minutes. And as I said, these links will be also underneath the rebroadcast of our of this session. And that rebroadcast usually gets up either the night after or the morning after. And you can catch up on other ones there as well. So again, I'll leave this up for a few minutes. I'll stay on the line, although I'll mute my mic for now. Again, my name is John Pearson, and I'm happy to answer any questions, whether you email them to me or ask away.